All right, so this is the final part. We'll just do these next two examples and we're finished. So here's example 2. So, and this is supposed to be, sorry, this is supposed to be a nice gentle warm-up for you, okay? We're not trying to get you stressing out about anything too much. Have a bit of fun with it. And, these equations are quite common. So you can have a go at, get used to solving them. They're quite fun. You can check that the solution is a solution. You can differentiate it and calculate it. So, I didn't show you that on the examples, but you can, easily check and verify its solution is correct. So remember, this will appear in the assignment, but it's just to warm you up and get you ready to do nonlinear characteristics. There's our curve. So we know from the theory that we can go out here that we have this formula that tells us that dx dt is equal to a of x comma t, which is, in this case, equal to t. All right? Now, it's a nice simple differential equation. I love how simple this comes down to. Lots of notation and ideas here, but in this particular example, we just integrate that. So we get x is equal to t squared over 2 plus c. So then we go, okay, u is, and on this curve, u is a constant. This is called the characteristic, isn't it? U is a constant. Okay, so that tells us that we've got u of t squared over 2 plus c comma t is a constant, and then we set t is equal to 0 as always, and we get u. I'll be more careful here, that's 0, that's c comma, there we go, messages coming up. All right, there's a lot of, you can tell a lot of stuff on the screen catch for personal information, I don't know. So I should be careful here to call this a constant, because I've already used c before. Right, it's a constant, it doesn't change, so I can change. So t is the u of c comma 0 is equal to f of c, and then I've just got to solve for what c is equal to. So I get, from here, when I rearrange this equation, I have c is x minus t squared over 2. So I get u of x comma t must be equal to f of c, which is equal to f of x minus t squared over 2. All right, and I'll just quickly show you what I probably should have shown you before. Okay, try green, that we can check the solution. Okay, so we've got, we can check the initial condition. When t is 0, we do indeed get f of x, and we have the time derivative of u is equal to minus t times f dashed, and the x derivative is just equal to f dashed. So it checks out. All right, I've got one last thing to do. I didn't call it example 3, I called it a non-homogeneous example. It's a bit more fun. So just remember that you've probably already seen all of this before. You might not have actually had to draw a picture of the characteristics or of the solution, which is what you're going to have to do in the assignment. Okay, non-homogeneous example. So we have dtu plus t dxu equals xt. X goes from minus infinity to infinity, t is greater than 0 as always, and u at t equals 0 is an arbitrary function. Okay, so we'll just derive this equation. So we've got big X of t, there's our characteristic, and we then find out what the time derivative of u on that curve is. What that is equal to is, as always, it's the x dt times the x derivative of u plus the time derivative of u, which is equal to dx dt times the x derivative of u plus, now the time derivative is t times dx du, sorry, I'm going to write this out properly, minus t times the x derivative of u plus x times t. Okay, we've got this extra term in it. So what we've got is, we've got the time derivative along here is equal to dx dt minus t times dxu plus xt. Okay, so now what we do here is we still solve for these characteristic equations. Now this is sort of solution by example. I haven't given you the formula for this, but it just follows. So we choose to solve, we choose dx dt minus t is equal to 0. Okay, it's the same curve we had before, right? X is equal to t squared over 2 plus c. And on this characteristic, it must be the case that d by dt of u is equal to not 0, not a constant, but x times t, which is of course equal to t cubed over 2 plus ct. Okay. So, we've got to solve that equation here. The time derivative of u is t cubed over 2 plus ct. So u must be equal to, on the characteristic, maybe it's equal, and maybe it's a good idea here to write this out explicitly, but this is u of x of t comma t. On that characteristic was equal to t to the 4th over 8 plus c t squared over 2 plus another constant. Okay, I'll just see here that I called it C2, and I'll also try and stick with the notation here, C2. Okay, then I go, okay, and then I'm just going to try and squeeze this in here. This is equal to u of x, rearranging this equation here, and jump back with my yellow, say, c must be equal to x minus t squared over 2. So, this is u of this is u of t, x is t squared over 2 minus c, t squared over 2, sorry, plus c, comma, t. Alright, and then we set t equals 0. So what we get is, we get u of 0, c comma 0, which is equal to f of c, must equal, from this expression here, c2. So c2 is f of c. Make that clear here. That's the result there. So now we can write down the solution. So we get u of x comma t is equal to t to the 4th over 8 plus c times t squared over 2. So that's t squared over 2 times this constant, which is x minus t squared over 2 plus c2, which is f of c, and c is equal to x minus t squared over 2. And that is the solution. Yeehaw. Sorry, just a little error here. So I get rid of that. Should be t to the 4. Right, I copied it down wrong. I just meant squared became an 8. And then if we can just finally simplify this, and we get t to the 8th minus t to the 4, t to the 4 to the 4. So we get minus t to the 4th over 8. Okay, taking that minus that, plus we get x t squared over 2 plus f of x minus t squared over 2. Alright, there's the answer. So I'm going to leave it there. That's the end of the first lecture. So remember in the assignment you've got to go and draw some pictures of these equations and draw some pictures of the characteristics in MATLAB. Just sketch the solutions out. It's not very tricky. It's just a matter of you're going to calculate the solution exactly and you're just going to plug the numbers in here. I'm trying to tidy that up there. Very bad handwriting. It's quite hard to write on these pads and I've got bad handwriting as it is. Okay, great. Finished though. We've done the first lecture. I'm pretty happy to have finished recording them as well.